raw earth shaped by hands is humanity's oldest technology. Today, a rotating array of craftsmen push raw materials from soft clay to volcanic stone and glowing steel to their absolute limits. The potter begins with a massive, leather-hard clay jar. At this precise stage of drying, the vessel is rigid enough to hold its shape, but soft enough to carve without chipping. He uses a fine-tipped metal tool to incise an intricate floral and aquatic relief. The curved, L-shaped scraper clears away the negative space. Removing this background, clay forces the remaining motif to stand out. It is a slow, unforgiving process. A single slip of the wrist could ruin the geometric balance of the entire piece. Sharp, deep cuts will also trap the glaze later, creating dark pools of color that emphasize the relief. The tool must remain perpendicular to the surface. It slices cleanly through the earthen matrix. By scraping away the outer layer, the craftsman exposes the slightly damper, darker clay beneath. This creates a bold contrast before firing even begins. Patience is the primary material here. Across the yard, the work shifts from delicate subtraction to brute force extraction. The quarry worker bores deep, vertical channels into a massive volcanic boulder using a heavy-duty electric hammer drill. Basalt and tuff are dense, igneous rocks born from rapid cooling. To split them, the worker relies on the ancient feather and wedge technique. Drilling establishes a line of structural weakness along the rock's natural grain. He then drives hardened steel wedges into the freshly cut cavities. Striking the wedges mechanically multiplies the force of the hammer blow. It directs thousands of pounds of outward pressure directly against the internal bonds of the stone. The friction holds the metal tight. Every impact widens an invisible microfracture deep inside the boulder. The spacing between each hole is critical. Too far apart, and the crack will wander off axis. Too close, and it wastes labor. The rock must yield. After the initial splitting, the shaping begins. An angle grinder, fitted with a diamond-tipped masonry blade, carves a deep grid into the porous surface. The spinning disc bites through the volcanic glass and compacted ash. This creates a precise fault line for the next break. Water pooling in the freshly cut grooves isn't just a byproduct of the environment. It acts as a vital coolant and lubricant. It prevents the diamond blade from warping under the extreme friction and suppresses hazardous silica dust. With the channel established, the worker returns to the steel wedges. He taps them rhythmically, listening to the changing pitch of the metal. A ringing tone means the wedge is seated tight. A dull thud signals the stone is beginning to separate. The grid of shallow cuts ensures the heavy block fractures exactly where the builder intends. The crack follows the path of least resistance. Slowly, the rough boulder yields to a stylized, ancient-looking face. The worker refines the contours using a smaller angle grinder, sending fine particulate into the air. Volcanic stone is highly textured and visually demanding. The craftsman must work with the existing voids and gas bubbles trapped within the matrix. A hammer and cold chisel remove the bulk material around the deep-set eyes and wide nose. Hand tools offer the tactile feedback that power tools destroy. The chisel finds the natural cleavage planes of the rock, breaking away large flakes with minimal effort. Deep cuts are made to separate the finished sculpture from the mother rock. Water cools the cutting disc during this final, decisive separation. The resulting sculpture carries the rugged history of the earth itself. Every chisel mark is a permanent record of the force applied. The massive weight is finally ready to move. Inside the sweltering glass studio, thermal mass dictates every movement. The glass blower hoists a glowing orb of molten material high into the air. Gravity immediately tries to pull the viscous liquid out of shape, requiring constant rhythmic rotation of the pipe. The glass is manipulated inside the furnace to maintain a precise working temperature. If it cools too quickly, internal stresses will cause it to shatter violently. Once the desired volume is gathered, it is pressed into a heavy pneumatic mold to establish its external dimensions. The neck of the newly formed bottle is then spot heated with a high-velocity gas torch. The concentrated blue flame melts only the targeted rim, allowing the worker to refine the opening without deforming the carefully shaped body. Below. To achieve custom colors, new batches must be continuously mixed. A chute delivers raw white powder and crushed blue frit directly into the intense heat of the furnace. The raw batch materials melt and fuse into a homogeneous liquid glass. The glass blower leans into the blistering, radiant heat, gathering the fresh melt onto a long steel blowpipe. At this temperature, the glass behaves like thick honey. He transfers the glowing mass to a metal workbench, rolling it to chill the outer skin slightly. This process, known as marvering, creates a stable exterior layer while keeping the core molten. The sphere is then seated into a dark, circular metal mold. Heat radiates from the yellow-orange core, ready for the final breath of air. Back in the ceramic shop, hundreds of glazed bowls await the fire. A worker navigates a towering cart of stacked ceramics into a massive, industrial-scale kiln. Stacking the cart requires strategic precision. The dense arrangement of bowls must allow for adequate airflow between the shelves, ensuring uniform heat distribution. If packed too tightly, cold spots will prevent the glaze from fully maturing. The heavy metal door is heavily insulated with refractory fiber to trap the extreme temperatures required for the firing schedule. Pushing the loaded cart takes immense physical effort. Once sealed inside, the raw clay and chemical glazes will undergo an irreversible vitrification process. The heat permanently alters their molecular structure. The slow cooling cycle is just as important as the heating, preventing thermal shock from cracking the finished wares. Hours later, the kiln yields uniform, shiny brown vessels, fully cured and ready for daily use. In the metal shop, precision engineering meets raw heat. A craftsman grinds a flat steel bar against a vertical belt sander, establishing a clean bevel. He then moves to the vise, using an angle grinder to cut a sequence of deep vertical notches into the spine. This creates a custom pattern that reduces the overall weight while adding grip. To enhance the design, small metal segments are hammered into the gaps. A welding torch instantly fuses these inserts into the parent steel. The localized heat of the weld creates a permanent metallurgical bond. However, welding also leaves behind slag and surface deformities. The craftsman grinds the fused spine completely smooth, hiding the complex joinery beneath a flawless finish. The result is a solid, continuous edge that hides the intense heat that formed it. A concentrated laser beam burns a precise maker's mark into the side of the finished blade. The focused light vaporizes the microscopic top layer of the steel, leaving a permanent etching without introducing structural weakness. The craftsman tests the edge on a sheet of paper. It slices effortlessly, revealing the knife's unique laminated construction. A wavy, copper-colored line runs the entire length of the cutting edge. This indicates a San Mai forged blade, where a hard carbon steel core is sandwiched between softer, protective outer layers, with copper acting as a visual and structural buffer. The polished wooden handle completes the tool. Across the forge, the scale of metalwork expands. Long tongs pull a glowing steel rod from the deep bed of a brick forge. At white-hot temperatures, the metal's crystalline structure becomes entirely plastic. A mechanical power hammer immediately strikes the steel, flattening it against the heavy anvil base. The machine delivers rapid, crushing blows that move mass exponentially faster than any hand tool could achieve. This intense mechanical working refines the grain structure of the steel, making it tougher and more resilient. A heavy steel die then stamps the flattened stock into a distinct, curved blade profile. The final stages of any build are defined by quiet, meticulous assembly. The craftsman tightly wraps a vibrant teal cord over the decorative fabric joint. This binding provides immense structural support, protecting the wood from splitting under tension while sealing out moisture. In the end, brute force and quiet precision operate as one system. Every hidden detail they carved, heated, and bound is what the tool's reliability now rests on. Form and function, finally complete.
상대. 다들 끝이야.